Hey everyone, so today we're going to be going over the Unit 1 Transformation Study Guide. So this is going to be helping you on your transformations test. So we're going to go through these. We'll start with translations and work our way through them. So the first question is asking, what's the rule for translating a point xy by AB? Well, again, translations, just remember those are slides. So we're sliding a figure left, right, up, or down. So all that's going to be doing is adding or subtracting these values from the original x and y. So our rule would be x plus a, y plus b. Again, all that means is we would add the a value. Now, if a is negative, then it'd be like a plus negative 2, for example. Well, then that would end up becoming subtraction. But this is the generic rule for translations. So if we try to apply that to the next one, so we want to translate the point 3, -5 by 4, 2. So again, I'm just kind of going to use this rule up here. So I'm going to have 3 plus 4 and -5 plus 2. Well, if I simplify that, 3 plus 4 is 7, and -5 plus 2 is -3. So my translated point here, 3, -5 by 4, 2. Well, I'm going to add 4 to this. 3 plus 4 is 7. -5 plus 2 is -3. So if we kind of do the same thing, putting it all together, and we do the last one here. So if I want to take a triangle with 3 points on it, right? So here are my vertices. And I'm going to translate it by -3, or sorry, -2, 3. So I'm going to take each of these and I'm going to subtract 2 from all of the x's. And I'm going to come in and add 3 to all of the y's. So something like that. So if I write the points now, 1 minus 2 is -1. 2 plus 3 is 5. This is going to be 3 minus 2, which is 1. 4 plus 3 is 7. And 5 minus 2 is 3. 6 plus 3 is 9. So those would be the 3 points for our translation by -2, 3. Again, if we kind of read this, this would be left 2, up 3. So we went left 2 from each of our x's, which is subtracting. And then we went up 3, which is adding to the y's. So that is translations. So here in a moment, we'll take a look at reflections. All right, so now we're going to take a look at reflections. So the first one is asking us, what's the rule for reflecting a point across the x-axis? And then what's the rule for reflecting across the y-axis? So if we're thinking of the x-axis, the way I like to remember it is if I'm reflecting or flipping over the x-axis, then I'm going to change the y value. So if we think of the x-axis, if we start off with xy, and I reflect across the x-axis, the y value is going to become the opposite. So we would say that xy then becomes x stays the same, y becomes the opposite. So the opposite is true for the y-axis. The y-axis, the rule would be x. Sorry about that. There we go. So x, y will then become -x, y. So again, the x value becomes the opposite and the y value stays the same. So let's use that logic here on number 5, where we want to take this point and reflect it across the y-axis. So we're going to be using this rule here. So if I start with my point, -3, 7, and I reflect it across the y-axis. Again, when I reflect across the y, the x value is going to change to the opposite. So if this is -3, this is now going to be +3, and that's going to stay 7. But just like that. So if I do the same thing for the last one, we just have a whole figure this time instead of 1 point. So I want to reflect across the x-axis for this one. So here I'm going to take each of these points and I'm going to change the y value to the opposite, but leave the x value the same. So this first one here would be 1. Well, that's +3. We're going to make it -3. Right here, we're going to leave the x value alone, leave that the same, make that 4, -4. Right here, we'll leave that -3 alone, and we'll change that -1 to a +1. And then the last point, 2, -5, we'll leave the 2 alone, and we'll change -5 to +5. So that's all you have to do for reflections. Again, the way I like to remember it is if I'm reflecting across the x-axis, the y value is changing. If I'm reflecting across the y-axis, then the x value is changing. So we'll take a look at rotations here in just a moment, but that will be your reflections. All right, so now we're going to talk about rotations. So rotations, again, turning a figure. So if you want to write that down, we're going to turn a figure around the origin here. So first thing, we're going to write down the rules for a counterclockwise rotation. So 90 degrees counterclockwise. Our rule would be xy, then becomes -y, x. And again, 90 counterclockwise is going to be the same as a 270 clockwise. So that's why the rule for those are the same. 180 counterclockwise or clockwise, they both are the same. That's going to be xy becomes -x, -y. And let me go back to this one real quick. When it's xy and it becomes -yx, that means we're going to flip the order of them. So the y value is now the new x, but it's the opposite, and the x value is the new y, but it stays the same. For 180, they stay this in the same order, but we're just going to take them and make them the opposite. So then the last one we have is going to be 270 counterclockwise. So 270 counterclockwise, it's going to be xy, and that's going to become y -x, the opposite of this. And again, 270 counterclockwise would be the same thing as 90 clockwise. So those rules will be the same, just like 90 counterclockwise is the same thing as 270 clockwise. So let's see if we can apply one of these rules to the next question here. So it says rotate this point here by 90 degrees counterclockwise. So if I come up here, this is the rule I'm going to be working with. So if I start with 4, -2, what I like to do is figure out which one's becoming the opposite. Well, in this case, the y is, and I like to circle that one. And then that's going to become the opposite, but the new x, well, the opposite of -2 is +2, and that's going to stay the same. And then finally, we're going to do the same thing, except now we have a triangle with 3 points, and we're going to rotate that by 180 degrees. So that'll be our blue rule up here. Again, doesn't tell us clockwise or counterclockwise because it does not matter which way we turn for 180. So here, 0, 0, that's just going to stay 0, 0 because the opposite of 0 is still 0. Well, this one, we're going to keep the order the same and just make them both the opposite. So -2, negative 3. This one's going to be negative 3, positive 1. Opposite of 3 is negative 3. Opposite of negative 1 is positive 1. So that is our section on rotations. We'll take a look at dilations next, and then we'll finish off with our reflectional and rotational symmetry. All right, so now let's take a look at dilations. Again, remember, dilations is making something larger or something smaller. Again, in math terms, we would say enlargement or reduction. So again, if you want to write that, this is going to be an enlargement or a reduction, depending on the scale factor. So if we look at number 10, it asks, what is the formula for dilating a point xy by a scale factor of k? Again, whenever I see scale factor of k, that is multiplying, right? So if I'm thinking of the rule, my rule is just going to be as simple as we're going to take k and multiply it by both x and y. So again, we'll get to an example of that down here. But the formula would be k x ky, meaning I'm going to take the scale factor and multiply it by the original x value, and I'm going to take the scale factor and multiply it by the y value. Which again, if we take a look right down below that, we're going to dilate the point negative 2, 5 by a scale factor of 3. So again, I'm going to take this point, negative 2 times 3, and 5 times 3. And again, if I simplify both of those, negative 2 times 3 is going to be negative 6. And 5 times 3 is 15. So this would be my new point dilated by a scale factor of 3. Again, negative 2 times 3 is negative 6, and 5 times 3 is 15. So again, the last one here, just like all the other ones, we have a full figure now with 4 points, so some sort of rectangle, and we want to dilate it by a scale factor of 0.5, which is the same as half. So we can think of it, we're taking half of each of these. So I'm going to come through here, and I'm just going to take half of each of my points. Well, half of 1 is 1/2. Half of 2 is 1. This one, half of 4 is 2. Half of 2 is 1. Right here, half of 4 is 2. Half of 5 is 2.5 or 5 over 2. I'll just put 2.5. And finally here, half of 1 is 1/2 or 0.5. And half of 5 is 2.5 or 5 over 2. So again, dilations, the key thing to take away here is, again, it's just multiplication. We're making something larger or we're making something smaller. And again, if we're talking about enlargement, that would be a scale factor of something larger than 1. So like the number 11 here with a scale factor of 3, that made it larger. This scale factor between 0 and 1 is going to make things smaller. So we see as we went from the original points to the new ones, all my points shrunk or reduced. So here in a second, we're going to take a look at reflectional and rotational symmetry, and then it'll be the last little bit of our study guide. All right, so our last little bit is on reflectional and rotational symmetry. So number 13 is asking us to define reflectional symmetry and give an example of a shape with this property. So again, if we want to define this, we would just say that reflectional symmetry is the same on both sides of a line of reflection or symmetry, either one. So it's the same on both sides of a line of reflection. So again, if we do a shape that has that property, I'm just going to do my best to draw. Let's do a rectangle. I'm trying to draw as the best I can. So if there's my rectangle and I wanted to show reflectional symmetry, I would kind of do a line right down the middle. And again, it's the same on both sides. And it would actually also have the horizontal one that I could reflect. It's the same on both sides. So both of those would be an example of reflectional symmetry, both the horizontal line and the vertical line. So rotational symmetry is when a shape is rotated and looks like the original. So shape is rotated, and looks like the original. So again, if I rotate some sort of shape, that shape would look like the same shape if I rotated a certain amount of degrees. In order to figure out the order, remember order is just number of turns. So depending on the amount of times that we could turn a shape, that would give us the order. So let's go back to the rectangle here. It's not perfect, but if there's my rectangle and I rotate it, it does not look the same yet. But boom, if I turn it like this, it looks the same, right? So if I keep going to where I get back, that was one time. That would be two times. So here, my order would be 2 because I could turn this rectangle twice to where it looks the same. And if we're thinking of angle of rotation, that's going to be 360 total degrees divided by the amount of turns we could make, which is the order, or 2. So that means every 180 degrees, my rectangle looks the same. So let's take a look at 15. 15 is saying if a regular pentagon, so I'll do my best to draw that. Something like that. And it wants to know, does a regular pentagon have reflectional symmetry, rotational symmetry, or both? And we'll explain why. So we'll cover reflectional symmetry. Well, the pentagon definitely has reflectional symmetry like that. And again, if I drew this perfectly, it should look the same like that. So this would also be like that. Oh, went the wrong way, like that, and like that. So in terms of reflectional symmetry, this would have 5 lines of symmetry. Rotational symmetry, well, if all my lines weren't there, I'm going to draw another little pentagon so we can see it a little better. Oh, man, not the best. But again, if I rotate that, if every side was the same exact length, that's supposed to make it look like the same thing. No, that's not the best image. But as I rotate this pentagon, it would look the same. If I was able to draw each side the same exact length, this would have rotational symmetry with an order of 5. I could turn it 5 times, which means the angle of rotation would be 360 divided by 5, or every 72 degrees, this would have symmetry, rotational symmetry. So again, that's just a little recap of reflectional and rotational symmetry, as well as all the other ones that we talked about. So hopefully you filled this out, and this will help you on your test. And again, if you have any questions, let me know in class, and I will help you.